When graphene was first isolated at the University of Manchester in 2004, it was described as a wonder material, a one-atom thick sheet of carbon that might be stronger than steel, lighter than aluminium, transparent, flexible, and an excellent conductor of heat and electricity. It was the kind of discovery that promised to reshape modern technology, and the scientists who extracted it won the 2010 Nobel Prize in Physics. But for years, progress seemed slow. Graphene was a miracle in theory, but not widely used across the marketplace. Now, 2 decades later, the story is finally beginning to change, as graphene has finally started to move from experimental novelty to manufactural product. One of the most significant developments is happening not in flashy consumer gadgets, but inside the hidden infrastructure of the digital world. Graphene's extraordinary conductivity and light handling properties allow data to move faster while using dramatically less energy. These new photonic chips reportedly reduce cooling requirements by as much as 80% in some small studies, which could be a potential game changer for the world's growing digital footprint. In constructions, engineers are incorporating graphene into low-carbon concrete, which reduces the need for cement, which is one of the most polluting materials on Earth. These developments show where graphene might quietly excel, from concrete to coatings, composites, sensors, and semiconductors. So the graphene revolution may not look like the sudden technological leap that we maybe once expected. Scientific revolutions rarely happen overnight. It took decades for silicon to go from being an obscure material to the backbone of modern computing. Graphene may follow a similar path, from laboratory curiosity to indispensable industrial material. So what we are witnessing now is the moment where graphene stops being a symbol of promise and starts becoming a real tool of progress.